Hi everyone, this is a brief video recording just to provide you some information in lieu of class on Friday, June 9th. And so our goals for this set of slides is just going to be to talk about scoring, or kind of how the measurement and evaluation piece of assessment is assigned. And we're going to talk about scoring within the context of both standardized assessment, and we'll pick up our discussion of norm referenced and criterion referenced scoring, and then we'll talk about scoring within the context of classroom assessment, where we'll talk about more traditional concepts like mean and standard deviation. So let's jump right in. I added this slide here since we talked about definitions for norm referenced and criterion referenced scoring in class. I thought it was just helpful to compare and contrast them to get at what their definitions are. And so as we talked about in class, norm referenced scoring would be something like a curved test in a large lecture class, or something like the SAT or the I-STEP. Those all tend to be norm reference tests. Whereas criterion reference tests are things like a lot of professional licensure exams, so for example the MCAT, or something like a driving exam. So sticking with those examples, we can think about what really differentiates norm referenced from criterion referenced scoring. And of course, at the most basic level, let me insert my table so I can compare and contrast more easily. At the most basic level, when we talk about norm reference scoring versus criterion reference scoring, it's how students' performance is compared or evaluated. So in the case of norm reference scoring, students' performance is compared to a normed reference sample. And we talked about that that's the distribution of scores from other students taking the test. So the performance is compared to normed reference sample. Whereas when we talk about criterion reference scoring, students' performance is compared to some set of criteria. So I just want to make a small note about what I mean by normed reference sample. So when we're talking about kind of most standardized tests, so something like the SAT or the I-STEP, the normed sample is literally hundreds of thousands of other students taking the same kind of test. So you have a very large sample, and you need a very large sample to be able to build the normal curve that we talked about to compare performance. Because if I built a normal curve, for example, out of the scores just in this class where there's only 9 of you, that wouldn't give me a very good normal curve. It wouldn't be enough of a distribution for me to be able to say, you know, this is a good estimate of your performance relative to other people. But when I have hundreds of thousands of students taking something like the SAT, I feel better about assigning a normed score, because I can say, you know, this is a good way to assign a score given that I'm comparing it to a very large sample of individuals. So I can really say how you're doing relative to everybody else. That's why you really only see curved tests in kind of very large lecture classes, when there's at least a couple hundred people taking the class, because then giving you kind of a relative score for performance makes sense. Of course, in criterion reference scoring, performance is compared to a set of criteria. And so this contrast leads to all of the other contrasts that we talk about when we're talking about norm reference versus criterion reference scoring. So with criterion reference scoring, you set the criteria a priori. And what that means is, before students even take a test, I set out what are the things that students are going to have to do in order to pass. What are the standards that they have to meet? Whereas for norm reference scoring, I can only set the normal curve after students have completed the test. So normed after the assessment. In other words, before you actually take the test, and the normed sample does too, I can't really tell you how you're going to do. So in the case of norm reference scoring, the score is assigned after everybody takes the test, whereas the criterion are set out a priori. Norm reference scoring, of course, means that your performance is compared to how other people doing the test performed, whereas that's not the case for criterion reference scoring. So based on other score based on test takers, which is not the case for criterion reference scoring. So score based only on individual performance. And then let's talk about what those scores look like for norm and criterion reference scoring. So the first thing we said is for norm reference scoring, you get a continuous score. That means that depending on where you fall relative to everybody else, you get some number. So for example, you got a 1600 on your SATs, or you get a certain score on the I-STEP. Whereas when we talk about criterion reference scoring, a lot of times we talk about just pass fail. So even if you get a score on your MCAT, the ultimate decision that comes out of that test and a lot of professional licensure exams is do you pass or do you fail? Same thing for the driving exam. The ultimate decision, regardless of how many points you get, is do you pass or do you fail? What that means is what scores indicate also differ. So when we're talking about a criterion reference scoring system, scores indicate that you met a set of criteria. So let me put that in. Scores indicate. And that's definitely not the case for norm reference scoring. Because with the norm reference scoring, what that means is that scores are relative. So let me put that in. Scores are relative, which means that you can get a high score may not mean high performance. In other words, if everybody else did poorly on the test, my score may be inflated because of that, but I may not have done very well on the test, kind of objectively speaking. And so what that means is kind of the reverse of that. Let me pull all this up. Is that when we're talking about norm reference scoring, it can potentially exaggerate differences in performance. So what that means is, let's say I have a class where students' scores didn't range very much. So everybody got basically between an 80 and a 90. So that's only a 10-point range. But if I force a normal curve, right, if I force there to be for students to fall according to a normal distribution, that means that somebody getting that 90 all of a sudden gets an A plus in the class, where on the test, whereas somebody getting that B minus, even though that's only a 10-point difference, would be getting a D or an F. So what it does is, if scores are close together, it forces them to be more dispersed. It forces them to be more normal. And so what that means is, kind of as a benefit, we are able to look at differences in students' performance. It differentiates performance. So that even if everybody in my class is kind of getting a B on the test, I'm able to say, who's doing better and who's doing worse. But of course, the downside of that is that it really exaggerates how students perform. So it doesn't really reflect the fact that, yes, you did below the mean, but look, how far apart your scores was within a fairly small interval, which is why you need a lot of students to have a good normal curve, because you don't want to build a normal curve based on just students' scores falling within a 10-point range, right? That doesn't give you a good normal curve. But the point of norm reference scoring is that it differentiates individual performance. It means that I'm going to be able to see how you as an individual student did relative to other students. Whereas with criterion reference scoring, it's difficult to compare. So all I know is that everybody passed the exam, or some people passed and some people didn't. But I don't really know, well, how well did you do relative to other people? Was it a kind of a high pass or was it a low pass? But of course, the big benefit of criterion reference scoring is that it makes sure that a set of criterion are met. What that means is that let me put that below, insert row below, oh, okay. What that means is that it makes sure that there are certain things that you're able to do regardless of how everybody else did. So going back to our driving example, a criterion referenced exam makes sure that you know how to parallel park. Or the teacher licensure exam makes sure that you know what are different learning disabilities or how to accommodate ELL students. Whereas in the case of norm reference scoring, you can still get a high grade or a good grade if everybody else likewise did very poorly without high performance. And I will say kind of the hidden benefit of that is that norm reference scoring allows us as teachers to correct for overly difficult tests. So that's the other reason why they're typically used in these kinds of large lecture classes. Because if it turns out that everybody did really poorly and I don't want to give everybody in my class a D, then I'm able to use norm reference scoring to say, okay, given how allows to correct overly difficult tests. So I can say, given that everybody in my class, nobody, got above a B, this is how all of you did relative to each other. And so then some people are able to get an A, even if the highest score in the class was a B. So it allows to correct for overly difficult tests. But what that means is students may still be getting an acceptable grade without a set of criteria necessarily being able to be met. And so all of these contrasts that I'm talking about within norm referenced and criterion referenced scoring really come from this fundamental principle of when we're talking about norm reference scoring, it's all comparative performance, how you're doing relative to other people. Which means on the one hand, if everybody does badly, that may boost your grade, but if everybody does kind of in the middle, then that may exaggerate differences or leave you with a lower grade than you otherwise would have gotten. Whereas when we're talking about criterion reference scoring, we're setting out a level of performance that you have to achieve. And so what we're doing is we're setting out a level of quality. But at the same time, that means that we can't really compare relative performance or individuals' performance to each other. So with thinking about these constructs and our definitions of norm referenced and criterion referenced scoring, I'm going to ask you to pause the video here and think about, for both norm referenced and criterion referenced scoring, what are the positives and negatives of each of these scoring approaches, and see if you can come up with 2 positives, 2 negatives for each. And I'll put a text box in here and fill in my own answers. So go ahead and pause the video. And let me move these over and we can work through them together. Let me make it so that you guys can actually see the outline of this box. 1, 2. Okay. And so the similarities and differences that we're going to be talking about really flow from really the definitions of what these scoring approaches are. And so norm reference scoring, the benefit is the kind of information that it gives you is it gives you comparative information on individuals' performance. So for example, if I'm looking at everybody who took the teacher licensure exam in the spring, I'm able to say, oh, well, that's a bad example because it's criterion reference. But if, for example, if I'm looking at students to admit based on SAT scores, I'm able to say, oh, you did better than other people. So I'm able to take the strongest based on kind of comparative information. Whereas criterion reference scoring, the whole purpose of it is that it ensures that essential criteria or essential standards of performance are met. Of course, a drawback of criterion referenced is we don't get a lot of variation in how individuals perform. So we don't know relative performance. I couldn't tell you based on a pass-fail criterion reference tests whether you did very, very well or just kind of well, whereas we get that gradation of performance when we talk about norm referenced. So it's not just comparative information, we get a continuous score, which allows us to have a little bit more information about how you did. Continuous score. But at the same time, criterion reference tests are much more easy to interpret, which is why, again, they're used for a lot of professional licensure exams. Because maybe if I'm a principal and I'm looking to hire a teacher, what I really care about is, do you have these basic competencies, yes or no? I don't want to spend time deciphering what a 700 on a particular exam means. I just want to know, have you met these standards? Of course, a con associated with norm reference tests is that students can get a good grade without mastering key content. and that it may exaggerate grades. And of course, we talked about that as happening in both directions. So on the one hand, if everybody did poorly, it could inflate your grade. On the other hand, if there wasn't a lot of dispersion in your grade, it could artificially lower or raise your grade because it kind of forces the normal curve. It forces them to have a gradation in performance. And so as a con, I would say doesn't allow everybody to get an all A's, or doesn't allow, unless everybody has the exact same score, it doesn't allow all students to have, for example, an A in the class. Even though theoretically your whole class could know the information, doesn't allow uniformly high performance. And as we talked about with norm reference scoring, you need a pretty large normed sample in order to be able to engage in this kind of grading, which is why we talk about both norm referenced and criterion referenced scoring as pertaining to standardized tests, because you need to have a large enough sample to be able to set the normal curve. So it's not something you would be necessarily probably able to do in your classroom. So it requires a large sample. Let me fix the spelling on that. Other benefits of criterion reference performing is hand in hand with ensuring that critical standards of performance are met. It also explicitly sets out those standards, which is helpful for test takers. It's helpful for those looking at the test. So if you're preparing, you know exactly what you need to know. Whereas in the case of norm reference tests, it all depends on who else is taking the test. So you don't quite have the same level of explicit information about what the test is asking for you. Explicitly set standards, which goes hand in hand with there being criteria. And of course, it ensures that everybody, that you reach a certain level of competency. It doesn't show relative performance. And of course, with criterion reference tests, the criteria matter a lot. I don't know if that's exactly a con, but what that means is you have to ensure that you're really identifying what are the essential pieces of knowledge that individuals have when I'm scoring this, and you have to ensure that you're willing to let them fail, really fail, if if they are not meeting one of those criteria. And of course, we talked about standardized tests as being high stakes, and I think that that really becomes very apparent in criterion reference scoring. So when you fail something like a professional licensure exam, that's really high stakes. So something like the bar exam, for if you're a lawyer, means that A, you can't do your job. You literally can't earn money. B, these tests tend to be pretty expensive, so a couple $100s to take them. And C, in the case of the bar exam, for example, you can only take it every 6 months. So failure is high stakes, and you can fail without kind of bombing it. You can fail if you don't meet just one of the criteria that are set out. And so that you're still failing even if your score was pretty low. And we can contrast that with norm reference scoring, which gives you a continuous score. Comparative information allows us to differentiate between individuals, and as we talked about, it also corrects for overly difficult or overly confusing tests that all students didn't do well on. You can still get an interpretable score by looking at how students are doing relative to one another. And so flowing from these strengths and limitations, we can think about the purpose of norm reference versus criterion reference scoring. And so we think about norm reference scoring when we're interested in this comparative piece, when we're interested in how you're doing relative to other people, and particularly in cases where we expect there to be a ceiling effect or a floor effect. So people do very, very well generally, but we want to be able to distinguish within that very well, or people do very, very poorly, but we still want to be able to distinguish within that very poorly. And so in those ways, norm reference testing can be a bit forgiving and can give you information on how individuals are doing relative to other people. Criterion reference tests work when there's a set of criteria you definitely want everybody to meet, and you don't care if everybody fails the exam because you feel like there is essential knowledge that students need to have. And so it's very helpful in terms of setting out those criteria. It's why it's used for professional licensure exams. And of course, it's very easy to interpret. It's very easy to say whether you passed or failed a particular exam. So moving on from criterion and norm reference scoring, like we said, a lot of times we don't see these in the classroom. And you can pause right here and kind of ask yourself the question of why you would think that would be the case. And of course, for norm reference scoring, it's because we need a fairly large sample in order to build a normal curve. But for criterion reference scoring, we don't tend to see it in the classroom because a lot of times it's not very helpful for us to tell students, you know, you passed or you failed English. We want to give students feedback, and we want to give students a score so they see kind of how much they mastered and they know when to improve. So we don't really use norm reference and criterion reference scoring for classroom assessment. What we use in the classroom is kind of measures that you're probably very familiar with, but I just want to go over these briefly. So when we're talking about scores on a test, and so in this case, I'll just tell you we're talking about classroom assessment that is formal and can be formative or summative if we're talking about something like a quiz, but tends to be summative. So when we're talking about a test. If I gave my students a test, there's generally 4 measures that I would be interested in looking at as a teacher if I want to give students their measurement and evaluation. So kind of give them a grade, help them with the interpretation. And we can break down these assessment measures in these scoring metrics into 2 categories. There are measures of what is called central tendency and dispersion. And when I talk about central tendency, you can kind of break that word down. And it tells you how students are doing at the center. Or I don't want to use the word on average, but kind of in the middle. So on average in that way. And when we talk about dispersion, you can think about how dispersed things are, right? So if I'm dispersing things, I'm spreading them apart. And so I'm interested in looking at how scores are in the middle, how they are kind of as a whole at the midpoint, and also how far apart they are. And so I know you're probably familiar with all of these measures, but I'm just going to go through them briefly. So when we talk about mean, what we mean is the arithmetic average. And so the way that we would get that is we would add up all of the scores in the class and divide them by the number of people. So the same way that you would compute a literal average. And so the average tells me kind of how my class did overall. The median tells me something similar. The way that we compute the median is if we arrange all of the scores in the class from lowest to highest. And so regardless of what the values actually are, we kind of count toward the middle. And the score in the middle is our median when scores are ranked from lowest to highest. And if we have an even number of students, then we take the 2 scores in the middle and we take their average. And so the median we can talk about as the midpoint. And so you're probably asking yourself, why do I care about the mean and the median? Why isn't the mean enough? And so for that, I'm going to ask you to do a quick math problem. So let's say you have the following scores in your class. Let's say you have a class of 5 students and they got an 80 and an 82. Well, let's do 90. They did better than that. They got a 90, a 92, a 90, a 91, and a 93. And, oh, but so 90, 92, 90, 91, but one student did really poorly, right? And they ended up getting a 50. So let's find what the average is going to be. I'm going to do that very quickly on my calculator. So I'm adding up 90 plus 92 plus 90 plus 91 plus 50. And that equals 413, and I'm dividing it by 5, which gives me an average of 82.6. So let's take these same scores and find the median. So in this case, I would arrange them from lowest to highest. So I would start with 50 over here, then my 2 90s, then 91, then 92. So same 5 scores. And then, oh, I messed up my formatting. That's going to drive me crazy. Sorry. Here we go. So let me delete these. And so my median is going to be, just if I move toward the middle, my median is going to be 90. And so now I'm going to ask you, which of these looks like the more accurate representation of the scores? And you probably said the median. And so the reason that we look at the mean and the median is because the mean is more influenced by outliers. And by outlier, let me just put a text box over here. By outliers, I mean extreme scores. And we'll talk about a more technical definition for that. But for now, we can talk about outliers as extreme scores. either extremely high or extremely low. And so in this case, the 50 would be the outlier. And as you can see, the mean is heavily affected by the outlier, whereas the median is not. And formulaically, you can see why that's the case. Because in the mean, the fact that there's a 50 here is taking into account when we compute the mean. It's one of the numbers I add into my formula. Whereas when we talk about the median, 50 is there, but it's just the lowest value. It's not added into the computation. And so that's why the median is sometimes a better measure of central tendency because it's not as influenced by outliers. And so now what I'm going to ask you to think about is looking at the relationship between the mean and the median. So for example, in this set of scores, the mean is lower than the median. What does that tell you about whether that outlier is disproportionately high or disproportionately low? In other words, if the mean is larger than the median, so let me put that into this text box so you can see it. So if the mean is larger than the median, does that mean that there is a high or low outlier or outliers? And if the median is larger than the mean, does that mean that there are high or low outliers? And I'll ask you to pause the video and think about that for a minute. And so you can probably tell from this example that if the outlier is lower than the other scores, in which case 50 is, the mean is going to be lower than the median. So the mean here is lower than the median, which means that there are disproportionately low outliers. And conversely, if we had a test, let's say, that somehow had over 100 points, so let's say the outlier was disproportionately high, then our average would be, let's add it up, that comes to 513 divided by 5. Our average becomes 102. I'll correct this in a second so it's not messy. Whereas our median, just because I would be deleting this 50 and adding a 150, our median would become 91. And you can see in this case, the 91 is still a better reflection of the scores than the 102. So when there's an outlier, the median gives us a better measure of central tendency. But as you can see, when the outlier is disproportionately high, the mean is bigger than the median. And so the way that I like to think about this is that the outlier pulls the mean toward itself. So when the outlier is disproportionately high, it's going to make the mean higher than the median. Whereas when the outlier is disproportionately low, it's going to make the mean less than the median. And so that's the relationship I want to think about when I'm looking at students' test scores. So let me put back my 50 and put back my 50 so that this is a nice clean example for you guys. But it gets to the point where I want to look at both the mean and the median because I want to know how is the central tendency for the class affected by outliers. So let's say I told you that students in your class had an average test score of 85. You'd probably think that was pretty good and you'd say, they pretty much get the content. That sounds good. But a lot of times the mean doesn't give us the full picture. So what if I told you that with that 85, the range of grades, and range is of course the difference between the highest and the lowest value, and that's an absolute value. So kind of the difference between the highest score on the test and the lowest score on the test. So what if I told you that the range for our test with a mean of 85 was 30? What that tells me is that while some people got 100, some people got a 70. Well, that may be pretty troubling for me as a teacher because even if my average is an 85, there's always going to be people below the mean. And it sounds like those people aren't getting kind of 80s. It sounds like those people are getting, a C minus, which is something that I might be concerned about. And we can think about an even bigger range. So range tells us how far dispersed students' scores are. And so it's the difference between the minimum and the maximum. And of course, within that, what I want to pay attention to is the minimum. Is there an outlier or an extreme score of somebody who is doing disproportionately poorly that I should be concerned about. And so the last measure of dispersion that I want to talk about is standard deviation. And so standard deviation, you've all probably heard of it. And so I'm going to ask you to pause it and see if you can define it for yourselves. And I'll define it in parentheses. So let me say it first because it's a little bit hard to break down. But the standard deviation is the average difference from the average. What does that mean? That means that, let me move this over here. Finally, some room. The standard deviation is the average distance of scores from the average or from the mean. So if I have an 85 as the mean for my class, and I have a range of, let's say, 30 points, which means that students, let's make it a little bit bigger. Let's make it 40 points, which means that if it's a 100-point test, that students got between 100 and 60 points, 100 and a 60 on the test. So already I'm a bit concerned because there's some students who are failing the test. The standard deviation could be something like, let's say, 5 points. The way I would interpret that is students' scores on average were 5 points away from the mean. So what that means is, I'm using the word mean a lot. So what that means is that on average, students' scores were between a 90 and an 80. So when we talk about standard deviation, we talk about scores falling on both sides of the mean. And when we say student scores were within one standard deviation of the mean, we mean that student scores were between, if our mean is 85, between 80 and 90. And if we say that student scores were within 2 standard deviations of the mean, that would be 10 points. So student scores would be between 75 and 95. So the standard deviation is the average distance of scores from the mean. So what does that mean if my standard deviation is 5 points versus my standard deviation is 10 points? What that means is it's asking the question of how closely concentrated students' scores are. And so generally speaking, I want a small-ish standard deviation. So I like 5 points because that means that if my mean is pretty good, if it's 85, and most students are doing within 5 points of the mean, between 80 and 90, that not only is my class generally doing well, which is what this measure of central tendency tells me, the majority of students are doing very solidly. So most of them are kind of within that range, even though, of course, we have somebody who's getting a 60. But on average, students are within 5 points. Whereas if scores are more dispersed, what that means is I have some students getting 95s and some students getting 75s. So on average, students are getting within 10 points, but that means that there's a much wider gradation of abilities. And so as a teacher, that's challenging for me in terms of differentiation. Of course, sometimes we do want a high standard deviation, especially on something like a diagnostic assessment or a formative assessment, because that can help me group students into, for example, high and low levels. If there's a high standard deviation, it can make that grouping easier for me. I also don't want a super small standard deviation. So for example, if my standard deviation is only 3 points, so students are really getting scores all close together, that could mean a couple of things. It could be that students all have the same misconception, so they're all missing the same part of an assessment. It could also mean that my assessment was too easy a lot of times. So I want my assessment to show me some differentiation in where students are so I can give them appropriate feedback. But I don't necessarily want there to be too much dispersion on my assessment. And so those are the 4 measures of mean, median, range, and standard deviation that I would compute and look at when I'm grading a classroom assessment. Just a note, this formula over here, you don't ever have to know it on a test, but I think sometimes it helps to see the formula for standard deviation to understand what it is. So I'm going to break it down for you, but if you have no interest in this formula, feel free to fast forward through the next 30 seconds. But the way that we compute standard deviation is we start by taking x bar, which is of course the class average, which would be 85, and we subtract every single individual score from the 85. So that's what the sum, the sigma here means. So we take every individual score. So if a student got a 90 minus 85, we take, okay, 5 points. If a student got a 92 minus 85, okay, 7 points. So we add up the difference between every individual score and the mean for the class. And then we square that. And so the reason that we square those values and square root is because with standard deviation, I don't care if a student's score is higher or lower than the mean. So I don't care if you got a 90, which is 5 points above the mean, or an 80, which is 5 points below the mean. I only care that your score is 5 points away from the mean. But of course, if I subtract an 80 from 85, I'm going to get a negative value. So we square and square root to essentially get the absolute value of the difference between each individual score and the mean. And then we divide it by the total number of students. And you can ignore the -1. It's kind of a formulaic thing in there. But that's how we get the standard deviation as the average difference of students' scores from the mean. And just kind of a neat property that I want to talk to you about, and I don't have a picture of a normal curve in these slides, is if you want to know how many scores fall within a standard deviation on a normal curve, the typical rule is about 66%, or about 2/3 of students' scores are going to be within one standard deviation of the mean. What that means is if my average is an 85, then 2/3 of students are going to get between an 80 and a 90 within one standard deviation. And so if you want to know the technical definition of an outlier, it's typically talked about as scores that are more than 2 standard deviations from the mean. So in this case, if students got 2 standard deviations from the mean, so above a 95, I would think they did really amazingly relative to the class. They would be outliers. And conversely, if students got below a 75, or 2 standard deviations below the mean, I would think they did particularly poorly on my assessment. They would be negative outliers, and I would be concerned about their performance. And so I'm going to end here, and we're going to pick up here with thinking about how to interpret scores given what we know about mean, median, range, and standard deviation. So just to review what we went over in this video, we talked about scoring procedures for standardized assessments, and those tend to be scored as either norm referenced or criterion referenced, depending on our purpose for scoring those assessments. And we talked about how we would score classroom assessments. And in that case, as a teacher, I would look at 2 measures of central tendency, specifically the mean and the median, and I would look at 2 measures of dispersion, specifically the range and the standard deviation. And that's where we will pick up on Monday. Have a great weekend, everybody.